Oh no.
No problem. We'll start recording from here. So still, just for the recording purposes, we are discussing what vertical circular motion, and we derived it two formulas. One is basically the velocity at any general angle theta with the vertical bottom, this one, and the formula for that is basically this much. And how did we apply, how did we get the formula for velocity? By applying work energy theorem from the initial point to the final point. And basically we derived one more formula, which is for finding out the tension in the string at any general angle theta. Okay, so we discussed two formulas. One formula is v is basically under root of u square minus 2gl into 1 minus cos theta, and the tension has three terms: mu square by l, 3 mg cos theta minus 2mg. Okay, so these were the two formulas which I was talking about, and with the help of these two formulas, we'll be deciding the whole work power energy, whole vertical circular motion chapter, or basically the article. So if you have done till here, then please write the next heading: angular amplitude of a pendulum. Please remember, this pendulum is basically called as a simple pendulum. Whenever you have a mass tied to a string, it is a simple pendulum. Okay. So now, guys, suppose I have this support and all, or basically whatever. If you want to make the support like this, or just support as a point, it's up to you. So suppose you have a simple pendulum in which you have a string and you have a mass m connected, and let's say you have thrown this with a speed u. So what do you mean by amplitude? Amplitude is basically the farthest distance from the mean position, right? Yes or no? So let's say when it was going from this point to this point, let's say at point C it stops. So will this be the extreme position? Yes or no? And will this be the mean position? Guys, whenever you throw a pendulum at the bottom, does it starts oscillating like this if you don't throw it with a greater speed, right? So at one particular position when it goes, it stops, right? So this angle at which it stops, this angle is denoted as phi. Well, how do we define it? It is the maximum angle till which the bob will reach with respect to vertical bottom. Please remember, by vertical bottom I meant this line, okay? This line. Because sometimes this might happen that this block, this bob may go above 90 degrees. This angle may be above 90 degrees. We go in the second quadrant like this, and then it may come back. Okay, so this thing is also possible. So that's why I'm just talking about this vertical part. So the maximum angle till which the bob will reach with respect to vertical bottom is called as the angular amplitude of pendulum. Okay, so if phi is the angular pendulum, so if phi is the angular amplitude, then can I say this particular thing at theta is equal to phi, at an angle which is equal to phi, will the velocity of the object be zero? Yes or no? Can I say this? Can I say this? Tell me yes or no.
Yes, sir.
If I can say this particular thing, that implies I can apply the formula as well. So under root of u square minus 2gl into 1 minus cos. In place of cos theta, what will I write? I'll write phi, yes or no, is equals to 0. A velocity is 0, basically that means this is 0, right? Yes or no? And can I solve it further? U square will be equals to twice of gl into 1 minus cos phi. So 1 minus cos phi is equals to u square by 2gl. And can you see from here cos phi will be equals to 1 minus u square by 2gl. Or I can solve it further. Phi will be equals to cos inverse of 2gl minus u square by 2. So this is one of the formula, 2gl minus u square upon 2gl. Once you have done noting down till here, we'll see one more angle. And you'll find similarities in the formula. Don't worry, it won't be like the formulas are complicated and all. No, no, no. You'll see similarities. Then shall I scroll up?
Yes, sir. Yes, sir.
Shall I scroll down? Everyone done writing till here?
Yes, sir. Yes, partner.
Now we'll discuss one more angle. The angle at which the string is slacked. Basically, where the string, wherever the string is slack, that implies the angle at which the tension in the string becomes 0. So basically, we are trying to find out that angle at which the tension in the string becomes 0. Sir, why is it important? Is it important? Yes or no? The importance of this thing you will know when we'll discuss the special cases. Okay. So basically, we need to find out at what will be the value of theta. So that let's say theta is equals to beta. The tension in the string is approximately equal to 0. For example, when this will be the case. When the angle will be equals to beta, the tension in the string will become zero. We'll see in different cases what happens when you throw it with this velocity and all. We'll see that. Okay. Now see over here. What was the formula for tension? Was it mu square by L plus 3 mg cos theta minus 2 mg? Was the formula like this?
Yes, sir.
And I want an angle where the tension is zero. So from this equation, I can put tension equals to zero. Mu square by L plus 3 mg cos. At place of theta, I'll have to write beta
Beta.
minus 2 mg. So can I solve this a little bit? So can you see this 2 mg will go over in that side, so twice of mg. This mu square by L will go on that side, so minus mu square by L is basically equals to 3 mg cos beta. Yes or no? Will it be like this?
Yes, sir.
And can you say I can take the LCM? I can send this L on that side. M and M will be cancelled from the whole equation. So it will be twice of Lg minus u square divided by, there will be one L in the bottom. Yes or no?
Yes, sir.
And then I'll transfer this 3 and g on the left hand side of the equation to get my cos beta. Yes or no? So from here, can you see beta will be equals to cos inverse of twice of gl minus u square upon 3gl. Can you see what is the only difference between the two formulas? What is the only difference between the two formulas? The place where the velocity was becoming zero, in that denominator it was 2gl, and where the tension is becoming zero in the denominator it is 3gl. The numerator is same. Are hai na?
Yes, sir.
Sania, getting any idea why did we use 2gl, under root of 2gl as the formulas and all, right? Thoda sa idea, can you see over here? This 2gl,
Yes, sir.
3gl. So from
Yes,
here,
sir.
now we'll see the cases. Okay. Acha, remember this particular thing. Remember this. Suppose if conceptually hai, remember this particular thing. Suppose if I say the whole vertical circular motion can be divided into 4 quadrants. Okay. Since we are starting and throwing the object from here, so I'll name this as my first quadrant. Okay. Here the theta will be from 0 to 90 degree. Here it will be from 90 to 180, right? And from here, in spite of taking the angle from the right hand side, you can take it from the left hand side, no problem, because whatever is happening in this part will be the same as this part, except only the directions would change. For example, the direction of velocity at this particular point is like this, and the velocity at this particular point at the same height, it's in this direction. At this point it is in this direction, at this point it is in this direction. The angle will be same, so don't worry. So remember, in the first half, in the upper half, in the lower half of this particular thing, in the lower half, whenever I talk about the lower half, there will be tension will be acting in this direction. Will tension be acting in this direction, and will there be mg in this direction? Yes or no?
Yes, sir.
So at this particular instant, can I say one of the components is opposing? Can you see one
Yes,
component of mg is opposing? But if I draw the same thing over here, if I try to draw it like this, velocity is in this direction, and the mg is acting in the downward direction, and tension is acting in this direction towards the center. Yes or no? Will the tension act in this direction? Mg act in this direction?
yes, sir.
So can you see over here in this particular place, if I say this angle is theta or whatever it is, can you see over here in the previous case, there was a chance in which I can balance the whole thing, right? Can you see in the previous case, one of the T was basically opposing basically mg cos theta.
Yes, sir.
In this case, can you see one of the component of mg will try and support support T, right? So if I'll say this in the upper half or basically the second quadrant, I'm talking about the second quadrant, in the upper half of the second and the third, in the upper half of the vertical circle, if the component of the weight becomes more than the tension in this thing. Can you see together this particular thing, the tension and mg, they are together providing what? The
The
centripetal force, right?
balance.
So what will happen
Yes, sir.
if the mg cos, the component mg cos component, if it becomes more than the tension in the string, then at that instant the string, or you can write the tension in the string becomes zero, because mg cos theta alone itself can provide the necessary centripetal force, so there is no need for tension anymore. So at that particular instant the tension in the string becomes zero and it becomes lagged. And can you see over this particular thing, if the string becomes lagged, then it will fall, it will not continue the vertical circle, and fall in just like a projectile motion. I'll just draw the diagram to make a clarity on this particular thing. In the lower half it will never happen. Why in the lower half it will never happen? Because tension, even if it is greater, it has to be greater than mg cos theta at that instant, then only it will be moving in a circular motion, right? So at this instant it is possible, but at this instant when T and the component of mg act in the same direction, so that's why at this particular instant we need to be careful. So if I draw this circle again, and if I say, let's say at an angle theta which is equals to beta, the tension in the string becomes zero. At this instance, whatever is the velocity of the object doesn't go in a vertical circle anymore, and it is just like when you have thrown an object from certain height at a certain angle and it goes like projectile like this, right? So the similar way, even this also goes like in a projectile motion till here and will become tight and go like this. Are you getting my point, guys? Are you
Yes,
understanding
sir.
what is
Yes,
happening in
sir.
the second
Yes, sir.
quadrant? So that is why we need to be very careful where the tension is zero in this thing. That is why this angle beta was important. Okay. So to make it into a, or we can say to make the object complete the vertical circle, the tension in the string has to be always The tension cannot be zero. Okay. What is the limiting case? When the circle is just barely or isn't it? What is the minimum condition for the complete circular motion? And which circular motion I'm talking about? I'm talking about the complete vertical circular motion. The tension at the top should always be greater than equal to zero. This is a very important condition. What is the limiting case? What is the minimum case which is possible? The tension at the top is equal to zero. That's the limiting case. Okay. So in spite of writing the limiting case over here, you can just write it as a note. Limiting case will be Chalo. Let's try it from the beginning. Have it done till here? Guys, is this concept clear? Okay, why the tension at the top has to be always there? The minimum case is basically the tension being zero at the top. And that too we need to throw it with certain speed, then only it will be happening.
Yes, sir.
Just tell me where to stop, okay? From where you need to copy.
So here. Full para.
Let me zoom out so you can have more things. So okay.
Yes, sir.
And I'll just be back in 2 minutes. Done, guys.
So the last para.
Don't worry, we'll study all these cases and all. Okay, with what velocity it will go up and all. So
So done.
So always remember, guys, at theta less than 90 degree, the tension can never be zero. and at theta greater than pi by 2, it is possible that tension may become 0. All things depend upon the velocity with which you have thrown it. Can you see? This also depends upon the velocity with which we have thrown it, and the previous angle also depends upon the velocity with which we have thrown it, right? So
Yes.
everything depends upon the velocity at which you have thrown the object. We'll discuss the cases. Different cases of projection. But before the cases, I'll just write the formulas again. Cos inverse of 2gl minus u square divided by 2gl.
So
This,
how will we remember these formulas?
do you remember 2gl minus u square?
Yeah.
But in the denominator, one time write 2gl, and in the second formula just write 3gl.
Okay.
This is all competitive. If you can't remember the formula, you always know how to do it, right? You know
Yes,
the
sir.
free body diagram, you know how to draw the free body diagram, and you know how to apply work energy theorem. Those are
Yes.
the basic things to get these formulas. This is basically the case when velocity is 0, and this is basically the case when tension is 0. Are you getting my point? So based on these two formulas, we have different cases. Case number 1. Can you see, if I say this 2gl and u square become equal,
So
okay?
then it's inverse cos theta.
If u square is equal to 2gl, that implies u is equals to under root 2gl. Now you are getting where exactly the cases come from. So when u is equals to under root of 2gl, can you tell me what will be the angular amplitude? This is the angular amplitude, and this is the point where the tension becomes 0. So when u square is under root of 2gl, can we say
So
phi
0.
will be cos inverse of 2gl minus u square will be 0. And what is cos inverse of 0? Are you, अच्छा तुमको inverse trigonometry नहीं आती होगी. So if cos inverse of 0, that implies cos phi is 0. This thing and this thing, they are one and the same. Okay. If you ever get confused, ki, sir, what have you written? Inverse trigonometry, then always remember this. You can do. If phi is cos inverse of 0, that implies cos phi is equals to 0. And when is phi equals to 0?
So 90 degrees.
So cos 90.
So that's why the angular amplitude is basically what? 90 degrees. And similarly, beta will be equals to what? Can you see? It is basically cos inverse of 2gl minus u square by 3gl. Yes or no? So here this also will become 0. That implies cos beta will also be 0 and beta will be 90 degrees. Sir, what is the interpretation of this result? The interpretation is very simple. When we throw an object with a speed u equals to under root of 2gl, then what is the maximum angle till which it reaches? The maximum angle till which it reaches is basically what?
The 90 degree.
90 degrees. Are you getting my point, guys? So basically, when you will throw it with this velocity, it will cover how much angle?
90 degree.
degree. And at this instant, the tension will also become 0.
0.
So this is what is meant by this result. When we throw the object with a speed u equals to root 2 gl, it completes the quarter circle and the string becomes horizontal. The string will become horizontal, yes or no? At this instant, the velocity will be 0 and as well as the tension will also be 0. So what will happen? After this, what will happen? It will come back like this. Will it be remaining like this only forever? Can it stop in midair?
No, sir. It'll come
So
back down.
it will come back. So basically what will happen? It will undergo oscillatory motion like this. Okay? Are you getting my point?
Yes, sir.
So can I say it starts oscillating in the lower half of the vertical circle? Can I say all these 3 points? The first point is this, second point is this.
So how does the string become horizontal?
Because the angular amplitude, see, the angular amplitude was 90 degree, right? So basically, where
Yes,
will
sir.
the bob stop? When the string will travel an angle of 90 degrees. So from here, 90 degrees basically this. From vertical to horizontal, 90 degree, right?
Okay. Yes, sir.
Acha, what will happen if you throw with a speed less than under root 2g? When velocity is less than under root 2gl, then what will happen? Will the string ever be horizontal?
No, sir.
So basically at that particular case, what will happen?
It'll come back.
So basically it will reach to a maximum amplitude phi and then it will come back, right? And go to the other side and will reach phi. So basically this will happen. Yes or no?
Yes, sir.
Yes, sir.
So from mean position to extreme position, from extreme to mean, then mean to other extreme and other extreme to mean again. So it will keep on oscillating like Is this clear? So what is the minimum velocity with which it has to be thrown? If I want it to cross the lower vertical circle, if I want it to enter into the horizontal circle, the upper half of the vertical circle, then tell me what is the minimum speed with which I shall throw this object at the bottom. Will it be equals to under root of 2gl?
Yes, sir.
So this is the first case. Shall we move on to the second case?
Yes, sir.
If you are done writing all this, then tell me. The case
So this
one.
all is JE point of view, right?
Yes, it
This
is.
won't come in school exam.
Never, ever. तूने पढ़ा क्या स्कूल में बता? Did you study this in school?
So school my teacher went too fast. Like she completed within 3-4 classes only.
Oh my God. No, that is too much fast.
Yes, sir. And then she took test also.
Even I'll be planning a test by the way, na? NLM without friction, NLM including everything. First, I'll be planning a test on two-dimensional motion because we didn't give any 2D paper, right? You gave only paper
Yes,
on 1D. So I'll be having a 2D paper and then we'll have one more paper based on NLM, Newton laws of
But
motion.
when? Any idea when?
So
I think 19th and 26th.
So Saturday's test, will it be like all 3 subjects or only one
No,
subject?
for now we are taking only chapter wise test. Once you will be done with enough syllabus, then we'll be taking a part test also. But generally those part tests, we never get time to take those part tests. Those part tests are taken at the
What
end of
Arnav is trying to ask is how does this one Saturday tests get commenced? Like how does it happen?
Google Drive, this Google Forms.
No, it's only one subject
One
per
subject
week.
only. One subject per week.
One subject
so
teacher just takes
Google
the
Forms
day and then he gives an exam on that day.
so Google Forms, so is it MCQ?
Yes, MCQ.
Yeah.
Oh.
Objective
No,
Everything.
it's
test
not
paper.
easy. It's very tough.
Hey, it's
Very
easy.
tough.
It is easy. You people
Sir,
are
no,
scoring good. You
sir.
should not say
It's so
that.
lengthy.
Sir,
So,
come
So
on. You are a
lengthy.
master. Sir, you're masters, sir. Come on.
but still,
We are
bhai,
just students.
it's like that paper is very easy. No? You could, you have finished that paper in 45 minutes and,
Sir,
done with
it's
the
easy because you're the master, sir. We are just students.
Sir, I don't even have to write JEE.
Acha.
My aim is SAT.
So what?
This
SAT
stuff will
also
give me
offers objective, no?
not taking subject test, general
So,
test.
you will be taking subject test next year, no?
Sir, but in physics is maybe. Mostly only math.
Only in maths, I think there is
Uh,
no MCQs. You just show working.
फिर देखना
So
पड़ेगा.
maths also there is MCQ sometimes.
There is, but most of it is working. Like you just take the picture and send it on
See,
WhatsApp.
the
to
point is
math.
not
Yeah.
the point is not whether the test is subjective or objective. The point is basically I would just want to know your ability to do things. If you are able to grasp the concept, if you are able to apply it, it doesn't matter the paper is subjective or objective. Okay. So I just want to check whether you have is your concepts clear and all, whether you can apply it or not. So that's the main concern. Since the mode is online as of now, so that's why even I am conducting these objective tests. Otherwise, this chapter test used to be like objective subjective mix. But for now, so we have to go for objective only. Even your school people might be taking objective, right?
Yes, sir. It's going on right now. I currently have my midterms.
तो वही तो मैं बोल रहा हूँ यार, जब तक it is like online education is there, तब तक we'll be following online, मतलब objective method, only taking the answers and all. Once I'm done, once this whole thing is over, Corona is over, then we'll start with the offline classes and all. Then we'll do that.
Is there a chance of the offline
Yeah,
classes
man.
opening
Not
anytime soon?
because literally speaking, I am not, seeing any conditions where this thing can happen. The cases are on a rise again, and
they're opening
Yeah,
schools in
today there are
India.
800.
And they're planning to open schools in India when India has 80,000 cases
I
in
don't
one
know
day.
what will happen in
India is messed up.
India
Sir,
is
you
really
should be
messed up.
knowing about the thing that happened in your hometown, yeah?
Yeah, I know.
Conducting
See,
procession.
it was like I told you already, it was like let me.
Okay.
So this was the first case, guys. Is this clear? When u is equals to under root of 2gl and when u is less than under root of 2gl, then what will happen? Okay. Now let's discuss case 2. Case 2 is when the velocity is under root of 4gl. So what is so important in 4gl? Can you see over here in this case of 4gl, if I put phi as cos inverse of 2gl minus u square by 2gl, was this the formula? Can you see over here, if I put u as under root of 4gl, that implies u square is 4gl. So 2gl minus 4gl will be how much? Minus 2gl, yes or no? So that minus 2gl and 2gl will get cancelled out, and this will be cos inverse of minus 1. Will it be? Yes or no? And when is cos phi minus 1? When phi is 180 degrees. That implies the angular amplitude is 180 degree. But what about beta? Can anyone tell me what about beta now? If I put it over here, if I put 4gl over here, so cos inverse of 2gl minus 4gl upon my 3gl, right? It will be minus of 2gl upon 3gl. Gl and gl will get cancelled out. Will it be only remaining is minus 2 by 3? Yes or no? Or we can say cos beta is equals to minus of 2 by 3. Cos is negative. In which quadrant is cos negative? since we are talking about only first and second quadrant, in first quadrant everything is positive, right? And is cos negative in the second quadrant? Guys, do you remember after school to college? All positive, only sine and cosec positive, tan and cot positive, and here the cos and sec are positive, right? Yes,
Yes,
or
sir.
no? So we know this rule already. Here only sine and cosec are positive. That implies cos is negative. So second quadrant we are talking about, right? When you find the
Yes.
value of cos inverse of -2/3, you will find that this angle is approximately equal to 131 degree. When you will find it using a calculator, you will find out beta is equals to 131 degree. And now, sir, what is the interpretation of this result then? The interpretation is simple. Now see over here, what was this phi? Phi is basically the angle where v is 0, right? So the velocity will be 0 at 180 degree. But can you see the tension is becoming 0 at 131 degree, right? It
Yes, sir.
means that whenever the bob is thrown with a velocity u equals to under root of 4 times of gf, then this bob wants to go to where? This bob wants to go to the top. Here the velocity will be 0. But when it is in midway, when it is at theta equals to 131 degree, at this particular point the tension in the string becomes 0. And I told you about that case. If the tension in the string will become 0, then it won't be able to complete the vertical circle anymore, and it will start moving in a projectile path. So basically, can you see in this case, when the velocity is under root of 4gl, what will happen? The speed at the bottom is sufficient to carry the bob to the topmost point. But tension in the string becomes 0 midway at theta approximately equals to 131 degree. So basically at this particular point the tension in the string will become 0. That implies the particle can't complete, or basically not the particle, we'll name it as the bob, right? The bob can't complete the vertical circle anymore, because what was driving it? The tension was driving it. And when the tension becomes 0, only mg cos theta is there. So mg, it is free falling, right? The bob can't complete the vertical circle anymore, and it will start moving in a projectile motion will start moving in projectile motion with a velocity. Achha, what will be the velocity over here? You remember the velocity was u square minus 2gl into cos theta, right? With the under root. Oh, sorry.
Yes, sir.
Not with the cos theta. 1 minus cos theta. Was the formula like this? Was the formula
Yes,
this?
sir.
So can you see over here, v will be equals to how much? What will be the velocity with which it will move? The speed at that particular point will be, basically, which speed am I talking about? This speed. Okay, we're talking about this speed. The formula is written for that only. So u square will be equals to 4gl minus twice of gl into 1 minus cos theta. And what is the value of cos theta? Theta is 131 degree.
So 131
So cos
minus
theta
2 by
will be
3.
minus 2 by 3. So can you see? Can you solve it?
Yes, sir.
4gl minus 2gl, 1 minus 2 by 3 is plus 5 by 3, right? So this is 4gl minus 10gl by 3. So this is ultimately the answer is 2gl. So the speed with which you are throwing it, this velocity will be 2gl by. Okay, and also you can find out this angle as well. Can you see if this theta is 131 degree, then what is this angle? What is this angle, guys?
So 49 degrees.
49 degrees. Okay. If this is 49, then this is 49 minus how much?
So 90 minus 49.
And that will be
Uh,
41.
41.
So
41.
this angle again will be what? 49 degree.
41 only, sir.
This will be 41, so this will be 49. No, this angle is 90.
Oh, yes, sir. Yes, sir.
So always remember the velocity with which it will be thrown at the top. This velocity will be under root of 2 by 3 gl, and the angle is basically 40. See, the main part is basically the interpretation. Okay, guys, the main part is only the interpretation part. Hai na? So remember this very well. At least remember the result. When the velocity is under root of 2gl, what happens? When the velocity is under root of 4gl, what happens? Okay. The last case is still left, which is basically when the velocity is under root of 5gl. हाँ देना किसका है ये खाने के लिए भूख लग रही है चल इधर नहीं बैगन उधर रखा है Guys, shall I scroll down?
Yes, sir. So finished.
ठीक है ओके सो ये क्लियर है डिड यू नोट टिल हियर
No, sir.
प्लीज नोट Done. Only I need to discuss this case and that's it for today. Okay. Now the last case, guys, it's the most easy case of all. And now you'll know the reason ki why have what the derivation in your school was and why is it so. Okay. So case 3 is when the velocity is under root of 5gl. I think you people might have only done this case, right? Guys, can you see I have just put the value of under root 5gl over here, and phi is basically cos inverse of minus 3 by 2. That implies cos phi is equals to minus 3 by 2. But we know this particular fact, guys. I think you people all know that the value of cos phi or any cos angle will always lie between 1 and minus 1, right?
Yes, sir.
So is this case possible? It is
No,
minus
sir.
1.5. So hence not possible. That is basically, what do you mean by that? There is no value of phi existing in this case.
So here would be assumed that it
The
takes an
velocity
entire,
will never become 0.
so it'll take an entire round.
It will take an entire round. But can you see over here at this particular case, the beta will be equals to cos inverse of 2gl minus 5gl divided by 3gl. Can you see I'm just changing the formula. यहाँ पे 2gl है denominator में, and here it is 3gl, right? So can you see over here cos inverse of minus 1, and we have already got the case of cos inverse of minus 1. So beta is equals to 180 degrees. So can you see over here the tension is becoming 0 at theta equals to 180 degree, and the velocity is not becoming 0. So can you see from here you get that case interpretation is that when the object is thrown with a velocity of under root of 5gl, then the object will never become 0 at any point on the vertical circle. But still, yes or no? The velocity is never becoming 0 at any point. That implies it will always complete the vertical circle. This is the first point you will notice over here. The second point is the tension at the top. Tension at the top. Can you see when the string becomes like this? Yes or no? Here it is moving with certain velocity. And when the angle is 180 degree, at that instant when the string becomes vertical again, the tension almost becomes, the tension in the string when the bob is at the top is 0. Even though the tension is 0, this is still moving, right? Yes or no? Even though the tension is becoming 0 at the top, but this object is moving with certain velocity, right? So will it stop over here? Hello? Will it stop at the top?
No,
When
sir,
the
I'll keep
bob is
going.
at the top,
I'll keep going.
it keeps on going. It's still, it keeps on going as it's have certain, as it has, certain velocity at the top. Is this clear? So even the tension becomes zero, the velocity is still there. And what will be the velocity at the top? It will be equal to u square minus 2gl under root, first of all, into 1 minus cos theta. Yes or no? So here put what? Theta as 180 degree and u square as 5gl. So I think you people can do it. 5gl minus 2gl into 1 minus cos 180 is minus 1. So this is 5gl minus 4gl, which is the velocity at the top is basically what? Under root of. Now you are getting the case from your school. Why did the teacher took the tension as 0? Why did you teacher took the velocity as under root of 5gl? Why did the velocity become under root gl at the top? Now is everything making sense? Yes or no, guys?
Yes, sir.
So what is the minimum velocity? The minimum velocity is this clear? Is this clear, guys? So in the next class, I'll do the school grade derivation for you people, what you have in your school. And then we'll see some more cases and some questions as well. Okay.
Okay.
Has everyone noted down till here?
Yes, sir.